Assalamu alaikum. Well, these are two questions from the same paper. Uh, May-June 2021, paper 1-3, question number 37 and question number 38. Let's discuss these two questions. Okay. Now, first of all, question number 37. The answer is marked, but we will going to solve it. Okay. Alright, now you can see here a circuit with a source of an EMF and also with an negligible internal resistance, and it has two paths, and from those two paths a current I1 and I2 is going. The current I1 and I2 in the resistors are as shown. Which equation is correct? And now they have mentioned an equation here, so probably we are expecting Kirchhoff's laws to solve this riddle. One of the equation is correct and we have to find out. Now if I opt Kirchhoff's first law, which tells about the distribution of current in the network or in the circuit, it's not going to be helpful here. Reason, it only talk about the current, the distribution of current, and the options provided here, you can see in the options over here, all they have current as well as the resistance values. So Kirchhoff's first law is not that helpful. So we will going to work out with the Kirchhoff's second law. According to Kirchhoff's second law, for a one provided loop, so if I just go with the battery terminal here and go with I1, this would be probably the one loop, and if I mark the second loop, that gonna be like this. So for first loop and a second loop, I have to work out accordingly. So let's take the first loop and apply the Kirchhoff's second law. According to Kirchhoff's second law, the sum of EMF must equal to, because there is only one source of battery, so sum of EMF must equal to the sum of the products of IRs across that loop. So I have considered the first loop for I1, so I1 R1 plus I2 R2. This is going to be the equation for the first loop according to Kirchhoff's second law. Mark it equation number 1. Similarly, now I'm making the second equation, and that would be from here till here, and the same battery is there. So like E is equals to I2 R3 and I2 R4. That is equation number 2. Now if I look at the left hand side of both the equations, this is and this is same, so I can write like this one: I1 R1 plus I2 R2 equals to I2 R3 plus I2 R4. Take out I1 common, so R1 plus R2, and bring that over here. R3 plus R4 must equals to 0. So if I look at this one, the right option is B. Okay, now let's talk about the next question. Same paper, question number 38 now, and we have kind of a sort of a potential involvement of a potentiometer along with other resistance. In the circuit shown, a potentiometer of total resistance 120 is connected in parallel with a resistance 150 and a resistance of resistance R. The battery has EMF with a negligible internal resistance, and the voltmeter reads 0 when the slider of the potentiometer is 1/4 of the way from its lower end. What is the resistance? What could be the value of R? Now one thing you must make sure, if you have this sort of circuit where a one resistor and another resistor, third resistor and the fourth resistor, and they all are connected, and in between either here like this, any meter is connected, either it's a voltmeter or ammeter or a galvanometer, and then obviously either this side or this side is going towards a battery, or maybe this side and this side is going to be the battery. This structure is actually called Wheatstone bridge setup, and it is a family member of potentiometer, by the way. So there is a potentiometer and the separate resistors, but this question will be solved with the help of the principle of Wheatstone bridge, And for that you need to memorize one thing, guys. Okay, and what is that? Imagine that is R1, R2, R3 and R4, or you can change the numberings, doesn't matter. But if the 4 resistors are connected like this and the meter reads 0 value, then the ratio R1 R3 is always equals to R2 and R4. This is an MCQ and you guys are preparing for it, the MCQ paper. You do not need a theoretical details, you need shortcuts. So you should remember the shortcuts about every particular topic, either it belongs to the DC circuits or the wave motion, right? This is a Wheatstone bridge principle. You only need to recognize it correctly and then apply this shortcut which I have just marked here. Now come to the question. He said the potentiometer slider is somehow 1/4 of the way from its lower end. So this is at this location, 1/4 of the way, and the full length of the potentiometer is offering how much amount? 120. So it means this portion will offer 120 divided by 4, 30 ohms. The one which I just shaded with the purple color, it's providing 30 ohms, and the remaining would offer 90 ohms out of 120. That's, we have make the 1/4 division of the total resistance for the potentiometer now. So technically above the meter the two resistors ratio is 90:150 must equal to 30 upon R. Why? Because the meter reads 0. So the R is equals to 150 into 30 divided by 90. Solve for the R. This we are getting 50 ohms, and that is the answer. Alright, thank you very much.